But in this section, that is a foundation course, I am going to start the subject of EDC. But this subject is given much importance in the GATE, you know very well. The number of chapters in EDC are very less. Only 4 chapters are there, you know very well. The first one is the semiconductor, second one is nothing but the PN junction diode, third one is the BJT, the fourth one is nothing but MOSFET. But in the foundation course, we are going to give much priority for the semiconductor. The student is perfect in semiconductors, they will do miracles in other chapters. If the student doesn't have the concept on semiconductors, they are unable to understand the other topics. That's why 10 days I have this subject. I am going to teach this subject, 10 days I am going to teach this subject. In 10 days, what that means, every Saturday and Sunday, I am going to teach the subject from 4 to 5 in the evening session. Understand my point now? That's why try to attend every one of the session properly and try to gain the knowledge of the more. That's my kind request. Understand my point now? Each and every one of the doubts will be clarified. The students are having any doubt, immediately they can arise. Yes, one student, Pragya Bath, hi sir, very happy to see you. Thank you, thank you. Yes, now the students are initially, before starting the subjects, just I want to inform you. The students who are willing to take the admission in IMS GATE Academy, they can go through it. They can go through it only now. The program features are given. 800 plus hours of the live classes with live interaction. And also given theory books, exercise books will be given by the IMS GATE Academy. The exercise books contains around 4,000 plus questions here now. 34 plus years GATE questions banks with video solutions available. They will give also now. And one-to-one mentorship sessions also done. 130 plus online tests are with video solutions of the mock tests and many more. If any student is willing to take the admission in IMS GATE Academy, just you call to this number, you will get the clear information. Understand my point now? The number you try to note down and have the contact with the people now. Understand now? I will start the subject now. Yes, I want to start the topic of semiconductors. I said already now. I want to do semiconductor topic. Semiconductors. Chapter is semiconductors. But directly I will not enter into the semiconductors. From the basics, I want to explain the subject. Even the student doesn't have any concepts of materials, here I will discuss. I want to start from the classification of the solids. But the solids are classified as insulator, conductor and semiconductor. You know very well. The first of all, in this subject, what I am going to discuss, that I will inform, then after I will start the subject. Wherever the theory part is required, that I will give clearly. And also wherever the analysis is required, that I will do perfectly. Wherever the problems are required, there I will do them now. These 3 points are taken into account to do the what now? Work here now. Understand my point now? Yes, I will start now. Solids are classified as 3 types, you know very well. One is said to be insulator. One is said to be insulator. The second one is said to be conductor. Conductor. The third one is said to be semiconductor. Semiconductor. There is one more material, that is a superconductor, that I will not discuss now. We need to discuss these 3 only now. Understand my point now. But initially, I would like to take the topic of insulator. Some information I will give. Conductor, then after semiconductor going now. But before entering into these what now solids, just I want to explain the types of the bands at first. types of the bands if you followed, we can enter into insulator at first. So before these three materials, I would like to give some information regarding types of bands. Because in the semiconducting materials, two theories very important, band theory and bond theory. These two theories are more important here now. You should understand. First we can see the bands. There are three types of the bands in any material. In the material, that is a insulator or conductor, you can find three bands. But in the conductor, one band will be missing only now. I will discuss now. One is said to be valence band. One is said to be valence band. The second one is said to be conduction band. Conduction band. The third one is said to be forbidden energy gap or forbidden energy band. Any name you can give. Forbidden energy band. Forbidden energy band. Otherwise, you can say forbidden energy gap also we can call. Any name you can give it. Understand my point now. But what is that band first of all? What is valence band? What is conduction band? Then we can discuss. Suppose I plotted a diagram like this. These are all the bands. This is nothing but one of the band. And second band I want to take here like this. Yes, like that I have drawn. This is said to be energy band diagram of any solid. This is said to be, which is said to be, and this is said to be valence band. This is valence band. This band is said to be conduction band. This is said to be conduction band. Forbidden energy gap or forbidden energy band is nothing but this portion. This is said to be forbidden energy band or gap, any name you can give. Like that I can write. So first we can discuss what is valence band. You take any atom. An atom contains nucleus at the center. Around the nucleus there are number of orbits. First orbit, second orbit, third orbit, like that number of orbits are possible. The electrons which are existing in the outermost orbit are called as, anybody can give the name? The electrons which are revolving in the outermost orbit are called as, anybody can give answer? What is the name given for the electrons which are revolving in the outermost orbit? Any student? Valence electrons. They were all away from the nucleus only possible here now, somewhat distance only now. So for example, a hydrogen atom if you got means there is a one electron, you can have one orbit only now. Two orbits are there now. In the second orbit, what those electrons are existing are said to be valence electrons only now. Anyhow, the electrons which are existing in the outermost orbit are called as a valence electron. But these valence electrons are going to lie in this band only now. The band in which valence electrons are existing are said to be valence band only now. In this band, that means this band is formed by the outermost orbit of an atom. But that outermost orbit is empty or otherwise partially filled or fully filled. empty is not possible. It may be partially filled or fully filled is possible. For example, 3 orbits you got. The first orbit is a filled, second orbit is a filled, third orbit may be partially filled or fully filled is possible. Understand point now, last orbit level now. That's why the electrons which are filled in the valence band are nothing but valence electrons only now. What energy they can have? The electrons which are existing in the valence band can have what energy level? Minimum energy or maximum energy. This is nothing but the maximum energy of electrons in the valence band. The electrons which are existing in the valence band are with maximum energy only now. All these electrons are existing. Suppose you take the material. For the material is existing at 0 Kelvin. For example, one semiconducting material I have taken. 0 Kelvin temperature is maintained. At the time, all the number of electrons are going to lie in the valence band. In the valence band only now. They will not move from valence band to conduction band. All the electrons in the valence band only at 0 Kelvin. In case we are applying the room temperature, around 300 Kelvin I have taken here now. Room temperature is 298, you know. But I said 300 Kelvin I apply. At the time, what is going to happen now? Electrons are liberated from the valence band. And those electrons will be reaching to the conduction band. Some electrons will go to the conduction band only, we can say. But you should not say the electrons, when they are liberated from the valence band and reaching to the conduction band, one after another, finally the valence band is going to become empty or not. Doesn't happen. Impossible. We cannot find valence band with empty only now. That may be partially it can exist or fully it can exist electrons only, we can say. Catching my point now. But what you could understand from the valence band, the band which is with number of valence electrons is called as a valence band. It contains what I said now, maximum energy of electrons only now in the valence band only now. Next one, but here the next one is nothing but the conduction band I gave it. But one more point you have to understand. In the valence band, electrons are existing, but they are not moving to the conduction band at 0 Kelvin. When the temperature is given, they are going to move, I said now. Why electrons are being only in the valence band? Why they are not reaching to the conduction band when you maintain 0 Kelvin? There is one reason. Here the electrons are existing. Suppose in an atom I selected, in an atom nucleus is existing that can have the positive charge. The valence electrons are away from the nucleus or somewhere it is existing. In one particular orbit, these electrons are existing. The attractive force, when the orbit level is a lower, first orbit and the electrons in the first orbit and nucleus, if it is taken, the force of attraction is a very strong. The nucleus attractive force is very strong on electrons which are existing in the first orbit. The gap is very less in the first orbit. When you go to the second orbit level, it is somewhat away from the nucleus only. The force of attraction is decreasing here now. Orbit levels are increasing more and more. The force of attraction between the electrons and nucleus will be reducing only, we can say. So electrons in the valence band are going to remain without movement, means the force of attraction from the nucleus is very strong. It doesn't allow the electrons to move from the valence band to conduction band only now at room temperature now. When electrons from the valence band can move to the next level, you should give some energy. That energy must be greater than the the force of attraction of the nucleus. Then what is going to happen now? Electrons are liberated and reaches to the conduction band only now. So to move the electrons from the valence band, what are the ways you can apply here? There are different ways. By means of the temperature, you can give the energy to the electrons to move from the valence band. That's the first point you have to remember. Temperature is one of the points to move the electrons from valence band to the conduction band level. Second one, by means of the you can say light energy also. By means of light energy, you can make the electrons to move from the valence band to conduction band. Second point. Third one, by means of connecting the external supply, you can make the electrons to move from this band to the next band level only now. That means one by means of the temperature, second one by means of the what now light energy, third one by means of the what now external supply. Practically nobody is going to use voltage, high voltage, the voltage is not applied generally. Theoretically we are saying temperature or light energy or external supply. External supply means what happen now? Voltage source you connect now. But the voltage source practically they are not connecting. Very high voltage is required to move the electrons from valence band to the next level band only now. Very high voltage that is required in kilovolts only now. Kilovolts of voltage is required means it's a more only now. Understand my point now. The breakdown of the material also possible in that case. That's why most practically they are going to use temperature or light energy only now to move the electrons from this band. That is the information from the what now valence band. What about the conduction band? Conduction band is nothing but the band which lies above the valence band. The band which lies above the valence band. Above this band it is existing only we can say. But it is empty band. Initially it is an empty. It doesn't have any number of electrons initially. Because at 0 Kelvin we are going to find all the electrons in the valence band only. Conduction band is empty. That means whatever, when you are giving the what now room temperature, some electrons will go and occupy the conduction band. Certain number of electrons only can occupy. That means minimum amount of the energy had by the electrons in the conduction band. In the conduction band, electrons can have the minimum potential. In the valence band, the electrons can have the maximum potential only. That's very important now. Anyhow, you follow now. But what is the why this conduction band? What is the purpose of this conduction band? Means you watch it now. What happens because of this conduction band? Suppose there is a material that may be a conductor or insulator or what now semiconductor, no problem. But in the what happen now whenever, but initially all the number of electrons are going to exist in the valence band only. All the number of electrons are going to exist only in the valence band initially. Now what happens now? I connected an external supply. I connected external supply to make the conduction in the material. Can you find any conduction in the material if I connected 10 volts or 20 volts? No conduction possible. Why no conduction is possible? When there are electrons in the conduction band, catch my point, when there are number of electrons in the conduction band, if you connected external supply, then only conduction of the material is possible. Current flow is possible. Without having any number of electrons in the conduction band, we cannot find flow of electrons in the material, even if you connected 10 volts or 20 volts or 30 volts only now. That is why what happens, the semiconductor material or any material, what happens now? First of all, they will allow the electrons to reach to the conduction band only now. That means what when I applied any temperature, you think it's so, certain number of electrons are reaching to the conduction band. Suppose I applied the potential, certain number of electrons reach to the conduction band. Then you try to apply the source to that material. That source can make these electrons to conduct only, you can say. Without having any electrons in the conduction band, you cannot find conduction of the current. That point is very, very important now. Understand my point now? So followed, I hope it now. What I said, valence band means what I said, the band which is with number of valence electron is nothing but the valence band. Conduction band means what I said, the band which lies above the what now, valence band is said to be the conduction band. In between these two bands, we got a gap. That gap is called as a forbidden energy band or forbidden energy gap, you can call now. In between these two bands, we got some gap only now. That gap we are going to call it as a forbidden energy gap only, we can say. But the forbidden energy gap depends upon what factor? Depends upon what factor? The type of the material. The type of the material is changing means the gap between these two bands will be changing only now. Insulator can have the what band, the forbidden energy band of more possible. Conductors, if it is taken, there is no band, forbidden energy gap. There is no forbidden energy gap. If you have taken the semiconducting material, the gap is very less is possible now. There's a based upon the type of the material, it is going to change forbidden energy gap. I can say that now. And one more point you have to understand. Temperature is also one more factor to change the forbidden energy gap of the material only now. That means when you are increasing the temperature in the material more and more and more, you think it's so. The time the forbidden energy gap is reducing only now. So reduction of the gap is possible by means of variation of the temperature also, we can say that now. That point is very important now. These three. And one more point you have to understand clearly now. But I applied some temperature. When I applied some temperature, what is going to happen now? Electrons are liberating. Electrons are liberating. The students may think when the electrons comes from the valence band, they may occupy the gap or not. The electrons which are liberated from the valence band can occupy any one of the place in the forbidden energy gap or not. Anybody can give answer. The electrons which are liberated from the valence band can occupy any place in the forbidden energy gap or not. It doesn't happen. We can't find. Whatever the number of electrons are liberated from the valence band directly reaches to the conduction band. Once a liberation of the electrons are done means directly they are reaching to the conduction band only now. We cannot find any number of electrons in the forbidden energy gap only now. That gap will be maintained as it is only, we can say. That point is very important now. These are all the three bands are possible in any type of the material only, we can say. I hope you followed. Now we can start these materials one by one. The first one I wish to select insulator. We must start from the insulator. Directly we cannot enter into the semiconductor. The energy band diagram of insulator I can draw like this. The energy band diagram of insulator I can plot like this. We know very well. Just now I explained this band, valence band and conduction band I explained. The energy band diagram of insulator I want to take. Of insulator. I said already this is the valence band, no doubt. This is nothing but the conduction band. But everybody knows the definition of the insulator. How we can define insulator? When you can say the given material is an insulator. If you don't find any conductivity in the material, we can say it as an insulator only. The material which does not allow electrons to pass through it is called as an insulator. The material which does not allow electrons to pass through it is called as a insulator. If you are connecting the supply of the more and more, it doesn't allow any number of electrons to move in the insulating material now. Why electrons are not moving? Why conduction is not taken place? Why there is a high resistance in the insulator? That we have to understand only, we can say. But here, in the insulating material, you can have the insulating material can have the concentration of electrons of the more or less. Try to understand. insulator, suppose I have taken the insulator, you can find atoms can have any atom number of electrons, I can write clearly, number of electrons in insulator are less only possible. Less concentration of electrons are possible in insulating material. But you know very well, semiconducting material, fourth group elements are said to be semiconducting material. Mostly fourth group elements comes under the what now? Semiconducting material, fundamental semiconducting material, germanium and silicon, most practically we are using. They were all fourth group elements only now. The fourth group elements means the atom which contains 4 valence electrons are said to be fourth group elements only now. But we cannot say all fourth group elements are said to be semiconductor. That word is not allowed. That sentence is not acceptable. But you have taken it for, as an example, you take the material like carbon, you take it for example. The carbon comes under fourth group element only now. It contains 4 valence electrons only now. Even there are 4 valence electrons, we cannot say there is a semiconducting material. That can act as a what? Insulator only now. Why it is acting as an insulator? The concentration of total number of electrons in a material are less number of electrons in what now? In insulating materials are very less only possible. When number of electrons are less, number of orbits required in an atom are less only. Electrons are more are there in the material, you think it so. Orbits required in the what now? Atom also more required. Here I say number of electrons less means number of orbits required. Number of orbits required to fill the electrons in the orbit, to fill the electrons must be less only. Why less are? Electrons are less only. More number of electrons, orbits also more only possible. Number of orbits are less means valence electrons are very close to the nucleus or away from the nucleus. Orbits are more are there now. Valence electrons, outermost electrons are far away from the nucleus possible. But here I am saying the number of electrons less. At the time, valence electrons are very close to the nucleus only possible. When they were very close to the nucleus, the force of attraction held between valence electrons and nucleus is very, very strong. When the force of attraction is very strong, all the number of electrons are going to lie in the valence band only now. They were unable to move. Even you are applying the more and more energy, they are unable to move. The reason is attractive force from the nucleus is a very, very strong, where in the insulating material only now. That's why what I wish to say, valence electrons are close to nucleus possible. Close to the nucleus. When the valence electrons are very close to the nucleus, the force of attraction held between valence electrons and nucleus is strong or weak means very, very strong possible. That means you can write now, force of attraction between valence electrons and nucleus is very strong is possible, is very strong. This is possible very, very strong only now. Now you try to catch my points. This is the energy band diagram of the insulating material. This is the valence band, number of valence electrons are existing. These valence electrons are very close to the nucleus. It is going to have the attraction. The electrons are attracted by the nucleus. That is why they were able to move to the conduction band. I applied more and more energy, no chance to move the electrons from valence band to conduction band. So, when the attractive force is a very, very high, you think it's so. Catch my point. When the attractive force from the nucleus is very strong, the forbidden energy gap will be wide is possible. So wide is possible. When the attractive force, suppose the material you have taken, for example, there are number of atoms. Each atom contains so many number of electrons. Number of electrons means orbits also more possible. When orbits are more, valence electrons will be far away from the nucleus. When valence electrons are far away from the nucleus, the force of attraction from the nucleus is very, very less only possible. Very, very less only possible. The time, whenever you are finding the less force of attraction, the forbidden energy gap will be reducing only now possible now. That is why the forbidden energy gap is also depends upon the force of attraction of the nucleus in the material also very, very important now. Understand my point now? Yes, anyhow the force of attraction higher, it doesn't move any number of electrons with. That is why current is not passing through the insulator. You are getting the point, I think now. The material which does not allow electrons to pass through it is called as an insulator. Why the electrons are not passing? I am repeating a number of times because students must understand the basics. Why the electrons are not moving to the conduction band? Valence electrons are very close to the nucleus. The attractive force is very strong. Leave it that point. But when the force of attraction is a very strong, forbidden energy gap is a wide or not? It is a wide only possible. It is a wide only possible. For insulating materials, catch my point. For insulating material, the forbidden energy gap, minimum forbidden energy gap is 3 electron volts possible. More than 3 electron volts also possible now. When the type of the insulating material is changing, you think it's so. Forbidden energy gap also changing. Once in one of the competitive exam, it was asked a question. The diamond can have the forbidden energy gap of dash electron volts. Repeated question in many PSUs. The forbidden energy gap of diamond is dash electron volts. The diamond is about carbon concentration it is going to contain. Carbon can be had by the diamond only now. But that can have around 6 electron volts possible. 6 electrons, more than 3 electron volts whenever you are having, that material comes under what? Insulating material only now. But a diamond with 6 electron volts, it is a more than 3 electron volts, so comes under what? Insulating material only now. The diamond also. What are the examples of insulating material? There are number of material. There are number of material now. Backlight. Backlight we are going to use now. Where we are using backlight? Backlight is used for the sake of what now? Switches and holders. In the manufacturing of switches and what now? Holders, it is required insulating material now. That insulating material is made up of what? Backlight only we can say. And also gutta percha. Gutta percha is one of the example of the insulating material now. Submarine cables. Submarine cables are what? High voltage will know. That will be used now. Submarine cables are insulating materials only now. That material is a what now? Gutta percha. That is one of the insulating material only we can say now. Understand my now? Shellac. Shellac also one of the example of the insulating material. For varnishes, they are going to use shellac also then now. Understand my point now? Like that, so many examples are there now. Even in these are the insulating materials are used in the what now? In the electronics, how it is useful. I will explain one small example I will give. You can understand how the insulating materials are used in practical applications. Understand now? I will give now clarity. Suppose you have taken, I selected here, two plates of the capacitor I have taken here now. 2 plates of capacitor I selected. How this insulating material is used. Each and every material I will explain. Understand now. This is 2 plates of the capacitor. Two plates of the capacitor I have taken now. This is connected with, these 2 plates are connected with AC supply. I will draw one AC supply. One AC supply I connected here like this. There is an AC supply. The V I have taken here. But here the two plates of the capacitor I have taken here now. But you know very well, when AC supply is connected to the ideal capacitor, suppose one ideal capacitor, two plates of the capacitor can act as a, two plates of the what now? Two plates when you connect it such a way in a parallel manner now, it can act as a capacitor. But for ideal capacitor, the power consumption equal to how much I ask. The power consumed by the ideal capacitor is always 0. No power consumption possible, ideal case. Suppose what I did, in between the two plates of the capacitor, I used insulating material. But I used insulating material. This is acting as a dielectric material. It is used as a dielectric material only now. But what material you can use? You can use mica, you can use, even you have taken the paper, you can use in between the two plates only now. I connected AC supply. Now, can you find any power consumption across the two plates of the capacitor or not? You please tell me. In between two plates of the capacitor, can you find any power consumption or not? 100% it is going to take place, because there is an insulating material. Because of that material, power is consumed, and consumed power comes in the form of the heat. In the form of the heat, it can generating. A name given to that heat is nothing but dielectric heat. This is given a name, dielectric heat. How the insulating materials we can use in the electronics field, just I am giving the clarity. Dielectric heat we are going to call. That dielectric heat we are going to utilize in practical application. But how this dielectric heat is produced means, just now I said, due to consumption of the power. Sir, can you say how much amount of the power will be consumed in between the two plates of the capacitor? Yes, we can give. The power equal to, you know very well, VI cos phi. You know very well. From the electrical, you know, that formula it comes in AC fundamentals. The current through the what now? Here the two plates of the capacitor is connected. At the time, if I ask, can you find the current through this? One means voltage by capacitive reactance. Generally, you will write voltage by capacitive reactance is nothing but the current. Sir, all these are required in the electronic devices? Yes, required only now. Must. You must know the basics. In the foundation course, we need to give all these basics. Must. Xc equal to what? Capacitive reactance equal to what, sir? In the AC fundamentals, you know. Xc equal to what? 1 by 2 pi Fc. You know very well. 2 pi Fc. Formula they will use. 2 pi Fc. Suppose I am substituting in this current, and also that current I am substituting the power. Power equal to, I can write V. The I is nothing but V by Xc. Xc is nothing but 1 by 2 pi Fc means 2 pi Fc goes to numerator. 2 pi Fc is possible. And cos phi I have taken as it is into cos phi. Cos phi. Suppose the distance between the two plates of these two plates, this distance between these is nothing but, I have taken some delta x for example. Delta x I have taken for example. Even the distance between the two plates also I have taken delta x. The distance between these two also I have taken delta x. That means equal distance is existing. I selected like this only now. So capacitance of the capacitor you will calculate by using what formula generally? 2 pi f. Capacitance of the capacitor equal to A into epsilon naught epsilon r by distance between the two plates, d into cos phi. Suppose A means area of the cross section of the plates, delta x into delta x square is possible. D means distance between the two plates, you will get a delta x. So by using this formula, we can determine how much amount of the power is consumed because of the existence of the insulating material in between the two plates. We can calculate. So that consumed power comes in the form of the heat I said. The name given to that heat is nothing but the dielectric heat I said. how this heat is used in the practical application. That is more important. Mostly this dielectric heat is used, to improve the taste of the biscuits. In the biscuit manufacturing units, dielectric heat is utilized. Sir, how that is used in the biscuit manufacturing units? That means initially in the manufacturing process, what they will do to improve the taste of the biscuit, it should be given low temperature at first. Then after they are going to apply the high temperature only now. Low temperature is given only by means of dielectric heat only now. When this dielectric heat is given low temperature, it's going to rise the taste of the biscuit only now. That's why in order to increase the taste of the biscuits, we need to use dielectric heat. That's the first application. Second application, glue, Glue, glue. Glue is the sticky matter. It's a sticky matter. Two different materials to take it for example. Two different materials. But on the surface of the material, you apply the glue. You apply the glue and connect the second material. Connect. I want to connect these two materials. When I want to connect these two materials, I applied the glue. To dry up the glue in the sunlight, it requires 24 hours. Catch my point. To dry up the glue in the sunlight, it requires 24 hours. By means of this dielectric heat, 60 seconds are just enough for now. 60 seconds means 1 minute is just enough only, we can say. This way, to dry up the glue, it was used in the practical application. This is dielectric heat only now. The dielectric heat, where from you are achieving? Only by means of the insulating material only now. Third application, defrosting the frozen food, you need to use the dielectric heat. Defrosting the frozen food, what it means, sir? But you know very well, in the mostly whenever the food items are left over in the house, means what they will do? Even the 5-star, mostly in the restaurants only they are using this now. They are going to put in the fridge only now. In the fridge they are going to use now. Then what is going to happen now? The next day we are going to find frozen food only now. The food is frozen by the ice. But you want to defrost. If you want to defrost, means what is required? Temperature is required. The temperature is achieved by means of the dielectric heat only now. That's why dielectric heat applications I said 3. One is said to be in the biscuit manufacturing, it is used to improve the taste of the biscuit only now. Second one, to dry up the glue. If you are applying the dielectric heat, it requires 1 minute only, I said now. Third one I said, defrosting the frozen food, we need to use the dielectric heat only now. Like that, insulating materials are used in the practical applications only, we can say. So I said, what is the main application of this insulating materials only now? And we can go to the next material. The next one is nothing but the conductor. Conductor. This is the second material. Solid, second solid only now. The types of the solids we are discussing now. Conductor, how we can draw the conductor? The conductor is plotted like this. The energy band diagram of conductor I can draw like this. From this point to this point, I can say, it's okay, first I will draw, next I will explain. The one more is required. This is the energy band diagram of conductor I want to plot. And I can say from this point to this point is said to be valence band. This is the valence band. This is said to be valence band. This is said to be valence band. What about the conduction band? That band is drawn like this. That band is taken like this only now. Like this we can plot. Like that I can plot. This is the energy band diagram of conductor, I can say. This is the energy band diagram of conductor. Energy band diagram of conductor. I can draw. But I said from this point to this point is said to be valence band. Whatever the conduction bands are, that can be taken from this point to this point is to be taken as a conduction band. This is conduction band. This is the conduction band. But some portion is what now overlapped. From here to here valence band, from here to here the conduction band. Valence and conduction bands are overlapped. Some portion, you know. This portion is said to be this point to this point. This is the overlapping portion. This is given a name, overlapping portion. Overlapping portion. Overlapping portion I can call this. This is said to be overlapping portion. But are you finding any forbidden energy gap in this particular energy band diagram or not? Anybody? Any student can respond. Is it existing any forbidden energy gap or not in this particular energy band diagram? We don't find. There is no gap. That means the valence band is covered to some portion. From here to here we are saying the conduction band, both are overlapping. It doesn't appear any forbidden energy gap. That means it is we cannot find any forbidden energy gap. But in this case, what is going to happen? I said already in the insulating material, valence electrons are existing in the valence band only. Valence electrons are lying in the valence band. If you want to move to the conduction band, you need to apply the more and more energy, I said here now. Here not require any energy. There is no forbidden energy gap. Even at a 0 Kelvin, the free movement of electrons are possible in the conductors, I can say. Only we can find the free electrons. The semiconductors, you know very well. Electrons are existing, holes also existing, I said. What is the definition of the hole I will give in the semiconductor. But in the conducting material, in the conductors, we cannot find any number of holes, only electrons. The free electrons are plenty. They are going to move in a zigzag path. Not in one, but if you are not connecting any external supply, you think it's so. All the electrons in the material will move in a zigzag path. One electron will move and hit the other electron. Collision is done continuously, you know. That's going to take in the conductors, you know. But how you can define conductor? The material which allows electrons to pass through it is called as a what now? Conductor, you know. Any student can give the best example of conductor. What is the best example of conductor? Anybody? The material which comes in the first level for conductors, anybody can give answer? Gold, very costly material. But you know that already I said now, insulator, good insulator, diamond, 6 electron volts, very costly insulator, diamond. conductor, gold is the best example. The gold is a what that contains free electrons to the maximum only now. Next it comes silver. Next level is the silver. Like that one by one will come. Aluminum, all these will come now. So best conductor is the gold, next to silver, next to aluminum. It goes like that only, you can say. Understand my point now. But in the conductors, the current is passing very freely means, very easily means, reason is what? Sir, you only said the free electrons are moving, sir. Why free electrons are going to move easily in the conductor? That is very important now. What is going to happen? Number of electrons existing in the material, like conductor, is a more concentration of electrons, I said. Concentration of electrons in the conductor are more. Concentration of electrons more or less means you can say directly more electrons only possible in the conductor. Any conductor can have more concentration of electrons. Electrons are more means in an orbit you can find more number of orbits or less number of orbits. But one orbit is filled by the number of electrons only. First, because a number of electrons in an orbit can be calculated by 2n square, you know. N equal to first orbit, 2 into 1, 2. 2 electrons in the first orbit. Second orbit, n equal to 2, 2n square, 2 square, 4, 4 into 2, 8. 8 electrons in the second orbit. Third orbit, 2n cube, 3 cube, 3 square is a 9, 9 2s, 18 electrons possible. Like that, what you can say, concentration, but the electrons in each and every one of the orbit is going to be increased only, you can say. But here the concentration of electrons more possible in the conductor. So number of orbits here required are more or less. Number of electrons, number of orbits required are more only. When electrons concentration is more, to accommodate electrons in the orbit, we need more number of orbits. I say number of orbits required equal to more only possible. When number of orbits are more, valence electrons are being very close to the nucleus or far away from the nucleus. Orbits are more means nucleus is far away from the nucleus. That is we can write now. The nucleus is far away from valence electrons. It is a far away from the valence electrons. When the nucleus is far away from the valence electrons, the force of attraction held between them is a strong or weak. It is a very close means attractive force is very strong. If the nucleus is far away from the nucleus means attractive force is reducing only now. In the conductor, the force of attraction held between valence electrons and nucleus is very, very less. That you can write now. Force of attraction between nucleus and valence electrons is less or weak only possible. Very, very less, not less, very, very less in the conductor. When the force of attraction is a very less means what happen now, the valence electrons are not going to stay within their own orbit level. They will not stay. Attractive force very long, less only now. At the time what they will do, they will try to liberate, they will try to escape from the what now, valence final orbit only now. Those electrons will come out of their orbit only. That is why these electrons are freely moving in the material only, you can say, because attractive force is very weak from the nucleus. That is the reason the free movement of electrons are possible because of these points only, you can say now. Follow this point? That is going to take place here only now. But what are the good examples of the conductor also I gave it, gold, silver, like that I gave it now. But in these conductors, we should discuss the transport mechanism also. By using this transport mechanism only, we are going to discuss semiconductor. Without knowing the transport mechanism of the conductors, we can't do the rest of what now? Rest of subject only we can say. That's why I wish to explain transport mechanism. Transport mechanism. Of transport mechanism of conductors I want to discuss. But in the transport mechanism of the conductor, what we are going to discuss? First of those points I will give. In the next class, I will discuss one by one. What I will discuss means I will discuss what is mobility. I will discuss mobility. The next class that I will do tomorrow from 4 to 5 p.m. I will do these all. What is the mobility? What formula will be employed? Second one, how to find out the current density in conductor? We are going to discuss the current density in conductors. Current density in conductors. After finding the current density, I will discuss conductivity also. I will discuss conductivity also. What those formulae will be employed in finding the conductivity, we can discuss. The fourth point I will discuss resistivity of conductors. Resistivity of conductors. This also I will discuss. Conductor. These are all the points we are going to discuss in the next class. I hope so far you followed. Thank you all.